Okay, so we've been watching a couple of videos about calculating sides and angles using the cosine rule. I want to just throw in an extra little fact that we need to be aware of when we're calculating angles using the sine rule. I want to just throw you back to one of the examples that we did when we were looking at calculating an angle, in this case here, the angle at D 72.2 degrees. You know that the size of the side opposite determines, is connected to the size of the actual angle. You can see here 57 degrees is connected to 5.2 centimeters. This other side here is 5.9 centimeters. It tells us that the angle opposite isn't going to be much bigger than 57 degrees. Okay, in this question here, we can be quite confident that the angle here is 72.2 degrees. That works quite well. Okay, but if you have a look here at sine D is 0.952. We trusted our calculator that the inverse sine of 0.952 was indeed 72.2, and it is. The only problem is there is another angle which gives us whose sine is 0.952. Okay, you might not be aware of it. I could tell you off the top of my head that the actual angle is 107.8 degrees. Now, if you were to go ahead and you were to do the sine of 107.8, you'll actually find that the sine of that is exactly the same. So for sine angles, if we're working backwards, if we know the ratio 0.952, we know this number, and we're working back to the angle, if we know our angle is acute, our calculator is going to give us the right answer every time, no problem. If you're told that the angle is obtuse, or you're asked to find the two possible values of an angle, then what you've got to do is work out a second one. Now, how did I know that it was 107.8? It's quite straightforward. I took 180 and I subtracted from that the angle that I had already calculated, 72.2, and if you do that, of course, you end up with 107.8. In other words, the supplement of the first angle that you find also is a possible size of the angle in some cases. In other words, just to clarify that, if I go on, I've got this wee slide here, the obtuse angle problem. In other words, if we want to work out for one of them, if we know an angle, then we can work out a second one. Just to quickly have a look at this here, if I said the sine of 30 is equal to the sine of what? Well, what I'm saying is that it's the supplement of 30, which is 150. If you want to take your calculator and check the values for both of these, you'll find they're exactly the same. The sine of 45 is therefore equal to the sine of whatever number you get, and you can do it in your head, or you can do a calculation, whatever. 180 take away 45 is going to be 135 degrees. Again, just why don't you check on your calculator that they are indeed the same? And what to do is just, you can pause the video here and check the other ones if you need to, and I'll go over the answers. Okay, so sine 60 is going to be the same as the sine of 120 degrees. Sine 135, 180 minus 135 is going to be this 45 degrees, as we found out earlier. Sine of 170, supplement of 170 is 10 degrees, and as we also saw before, the supplement of 150 is 30, right? So as long as you're able to identify the supplement of an angle, you can work out the other angle. So let's have a wee look at an example of this. It says here, calculate the size of the obtuse angle PRQ. PRQ is this one here. We've got some information about our triangle, so I can go ahead, P, Q and R. I can label my sides small r, small p, and small q. It's the sine rule we're dealing with, so if I write it out in full, I've got P over sine P equals Q over the sine of q equals r over the sine of r. Let's tick what we've got. We know q, small q, and small r. We don't know anything about p. We know the angle at q, so we can tick sine q. And we want to find capital R. We want to find the angle at r. So yep, that's good. We've got a circle and a tick, and then two ticks. We don't care about the fraction p. So I can go ahead and I can work out what's going to go into my fraction. Small q is 37 over the sine of 40 degrees is equal to small r 52 over the sine of r. I'll just keep calling it r for just now. So there we've got a situation where the unknown side's on the bottom. I'll just do a wee bit of cross multiplying just to get rid of those fractions. So 37 multiplied by the sine of r is equal to 52 multiplied by the sine of 40 degrees. And we want sine r on its own, so we want to divide by 37. So sine r equals 52 sine 40 all over 37. And that should give us a decimal number that we can go ahead and use in a moment. So we get 52 multiplied by the sine of 40. Make sure your calculator is in degrees mode, otherwise you're going to get this all wrong. Sine r is equal to 0.90337 and so on. I'm going to use to 3 decimal places 0.93. Okay. Now this is the issue here, because normally you would just do inverse sine. If you do shift sine, inverse sine of 0.903 we get. So let's go ahead and do this. R equals, I'll just write that, inverse sine of 0.903, and our calculator, it tells us that it's 64.55, 64.6 degrees. Okay? However, the size of angle R clearly is not that, because we're told it's obtuse. So this is like possible R is that's angle 1. Okay, the other possible value of R is going to be 180 minus that. So this is all you need to do. You need to remember that the other angle that's got the same sine decimal is going to be 180 minus that, and if you do that, you'll get 115.4 degrees. So which one is it? We've got two possible angles. We've got an acute angle and we've got an obtuse angle. Well, clearly we're told in the original question that we want the angle PRQ to be obtuse. Therefore, we're going to choose the obtuse option, 115.4. Okay, so we can write down angle PRQ is equal to 115.4 degrees. Some questions it might say find two possible values for the angle, in which case you would include both of them in your final answer. Some of them it just makes the point that it's the obtuse possibility, and therefore you basically get rid of the first possible answer. Don't leave that in as a possibility. Make sure your conclusion is that it is indeed the obtuse one. So hopefully that's helpful. There'll be some questions you can try where you can practice that. You can find that in exam type questions as well. So hopefully that's helpful.